So this talk is called A Shiny New Way of Rendering, and since everyone else is doing it, I had to change all of my slides to include emoji. Looking at some of the abstract, and maybe if you follow me on Twitter or GitHub or hear me rant in NashDev, you probably think that this is just a talk about Ember. I'm glad to say that it's not just about Ember, it's about Glimmer, and really it's about rendering in general. So this is things, hopefully, that we can take away for most frameworks. Of course, I'm going to kind of advertise and say why Glimmer and Ember are cool. But I think that there are some takeaways that I'm going to get to towards the end that help everyone. A little bit about myself. My name is Ryan Tablata. If you want to follow me on Twitter, @Ryan Tablata. If you want to find me on GitHub, I'm one of those weird people that doesn't have the same name everywhere, so it's @rtablata. And if you want fewer hot takes and only pictures of my dog, he has his own Twitter @EmperorPuppetine. And I'm going to include all these slides so you don't have to write things down real quick. And I'm going to tweet them out or send them out. I work for a company called Prototypal. We're a JavaScript and Ember consulting and product development company. And we also do Ember training and staff augmentation as well. So if you're interested in any of that, come talk to me. We also run a website called embercast.com where we're doing Ember training from the experts. So on our team, we have multiple people who are on the core team or learning team for Ember itself. So it's kind of like you're getting Ember training right from the experts, from people who have started basically with Ember since day one. And to break things down for my talk, I'm going to break things down into two parts. The first thing is looking at how we describe HTML. And I actually showed this to my family who don't code, and they're like, well, isn't that really basic? And I'm like, well, no, unfortunately not. But we're looking at how we describe things in JSX and handlebars. And then the second part is going to look at how we update the DOM. So what frameworks actually do with the code that we write, and how does that get to our end users? Because that's what happens at the end of the day, is what updates what the user sees. So I want to see a show of hands real quick. Who's used Glimmer.js? One person. Yes, that's better than I thought. All right, hopefully more. Who's used Ember.js? Whoa, okay. I see a few of my alumni, so that kind of counts. Even if it was like the old version, cool. Hopefully more people, or else the frame of reference for this talk is going to be really off base. Who's used React? Yes, good. If that was not a lot of hands, this would have been weird. So we have a good basis of understanding. Hopefully you've seen a little bit of React code. You've worked with JSX. So the first part is how we describe our HTML. And more importantly, what happens when we talk about what we write, so JSX, handlebars, Vue templates, I'm not going to go into that, or Angular directives and templates, and what that actually sends to the browser. Because the code that we write in our editor, all of us are probably using Webpack or Broccoli, or even if we're using older systems like Grunt and Browserify, we're doing some work on our code before it ever gets to the browser. And we need to know what the code the browser gets to be able to understand how this renders. So here's a basic JSX component, and I've had multiple React developers tell me that this is terrible and this is better than what I had originally written. But what I'm doing is returning an H1 that says hello and like a variable called conference. That's all I'm doing. The equivalent to this in handlebars is just H1, hello, double curly braces. Angular is pretty much the same. And when you look at JSX, a lot of people say, well, it's just JavaScript, right? I've got the render function, I've got ES6 classes, or I've got create class if you're using some older versions of React. And you're saying, well, JSX, you're just writing everything right inside your JavaScript, and it's just JavaScript. Well, I'm going to do something that's a little bit less controversial first and say, JSX, first of all, definitely is not just HTML. I can't go to my designer or my CSS guru who's invaluable to my team and take what they give me and just paste it into my editor and things work. I have to change class names, I have to change IDs, there's attributes that React does behind the scenes, and you have to look at the docs of like, why did this attribute all of a sudden not show up in the DOM? You can't just take regular HTML and just paste it in. There's extra work you have to do. Handlebars, you can literally take any HTML and just stick it in there. Scripts and stuff get escaped, and if you try to use curly braces, whatever. But if it's valid HTML that you have escaped or HTML special characters inside of it, HTML or Handlebars or Glimmer or an Ember can just consume that, put it on the page, and you're done. Which is really cool. You've already got the tools that you know. You don't have to learn any new syntax to just use static content. Now, stop, because there's an opinion ahead. And please don't at me. JSX is not just JavaScript, people. Because the first thing, I used to teach at a boot camp called the Iron Yard, and we teach JavaScript, and we teach decision tree making. We say, sometimes you want to do something, sometimes you want to do something else, and you use what? An if statement. And you go and you bring developers who've just learned JavaScript, or who've been using JavaScript for years, or have been using other programming languages where if statements are cool, and you say, okay, unordered list, sometimes I want to show the stuff for a logged in user, sometimes I want to show stuff for a not logged in user. But if you've used JSX before, you might know this is an issue. And you've probably seen me tweet this out too. Luckily with React 16, you can actually do something similar if you use a ternary operator, but actually there were multiple issues with that, and if you want to talk to me after the talk of what was changed in React 16, the if statement wasn't the only problem there. But now you can use what's called a ternary operator, which I think when you have multiple lines of code is kind of hard to read, and it doesn't go to our basic instincts. You have to start learning syntax that is quote unquote just JavaScript, but you have to learn where you can use some things in JavaScript and where you can't. You can't just take your existing knowledge of JavaScript and HTML and just all of a sudden combine them and say everything works like normal. But why? Why can't I use an if statement? Why can't I do this? And you're probably thinking, why am I just like making fun of if statements in the middle of a talk? But it's essential to know what happens when I write that JSX and what the browser is actually seeing when Webpack's done with it, or where Grunt or Gulp is done with it, or Babbel's done with it. Because remember, JSX is just JavaScript. But more appropriately, and yes, it's not as fun to say, JSX compiles to JavaScript. And it compiles to regular JavaScript that's readable, runnable, and executable. So if we take the input that we had from before, here's what we get out. We get what's called react.createElement, and it's running an actual function and passing in arguments and values. So what's happening is the hello conference that I had in the middle of that like HTML looking thing in my JSX actually gets passed in as an argument to this function. So the reason that the if statement actually doesn't work is because if we tried to use the if statement, it would be putting an if statement in the middle of our argument list, which is not valid JavaScript. Yes, there's a Webpack plugin that will turn if statements into ternaries. Don't want to deal with it. All right, so you're probably saying, isn't this how Handlebars works? The short answer is no. The long answer we're actually about to get into. It actually is very different. So Handlebars input from before, let's see what happens when you run it through your build process. This is what's called the Glimmer instruction set, or the Glimmer output. This is actually a JSON string, which we'll get to the performance benefits of that in a second. But what happens is each part of the HTML that I described then becomes an individual instruction. In computer science, this is very similar to something called the LLVM, which is like what a lot of iPhone and Android apps eventually compile to, like this instruction set that can be run on multiple devices in any language. So really, this is a JSON statement. I'm going to get in trouble for saying this, but this could be parsed and used in any language that you want to create UI elements. Do with that knowledge what you will. You're probably thinking, so what, who cares? For performance, this shouldn't really matter. But things get really cool. This output is actually really critical. And what I've got here is a meme from Tom Dale, which, if you know Tom, it's a thing, and I'll let you kind of read for a second. It's complete nonsense anyway, so I'm going to go to what this boils down to. So JSX on one hand, what we've learned so far and what happens if you start digging into what you have with JSX. You get all of JavaScript, right? You get that just JavaScript. You get all of the behavior and all of the dynamic and uncertainty that comes with JavaScript. Yes, we love it, but it also means that anything could happen in the render function. Lori yesterday talked about how require is cool, and most of us use it as a plain string and never mess with it, but technically you could put dynamic data in there and really screw things up and get unpredictable results. And what happens is that means that you can't do extra performance enhancements around that. It means that every component has to be evaluated completely every time you want to know what the HTML for a component is. And it means that we do get full dynamic data and full dynamic representation of what that data should look like, but we have a cost in that. Handlebars, on the other hand, it's simplified, it's constrained, it's just HTML for the most part, with extra syntax laid on top of it. There are dynamic things that you cannot do. There are things in JSX that you can do that you can't do in like Vue templates or Handlebars templates or Angular templates. But there's some other benefits. I talked about JSON, that template being a JSON string, but that means that JavaScript actually doesn't have to be evaluated or run until I use that component or that template. So if I send like my user admin screen, which is like a 1,000-line template or set of templates, JavaScript's never executed for that. And then even beyond that, what's cool is since it's represented as JSON data, it can be parsed incredibly fast because it knows it's not going to run into things like functions or delete keys or memory assignment. It knows that there's a much smaller subset of JavaScript that this object can represent, and it parses it incredibly quickly. Oh, and by the way, you can still copy and paste HTML. But you're still probably thinking, this doesn't look or feel that different, which is where we get into part 2. So we've got sort of an idea of what's the data that gets sent to the browser. What's the JavaScript or what's the JSON that gets sent to the browser? But what do frameworks like Ember and Angular and React do with this code? So I want to start with a little bit of a history lesson, because I want to know how rendering actually works and what we've done in the past. And really, why was React so huge? Why was it this like 60 frame a second unlocking mega thing that just blew everyone's mind away? And let's first look at Angular 1 because I think it's the easiest to explain. And it did what was called dirty checking. So if you had that component that had a conference variable, what Angular 1 would do, there were more performance enhancements around it, but at the lowest level, what Angular 1 would do is it would say, hey, are there any event listeners running right now or scroll handlers? Or is there any other JavaScript running? No? Cool. I want to go check what conference is. And then like 5 milliseconds later, it's like, hey, I need to go check what conference is. And I need to go check what conference is. And it would continually look at what the value is for this element. And if it changed, or if it's just been a while, it would send out an event to every element on the page saying, the value for conference has changed. And every element then has to go and listen for it and say, oh, conference has changed. I don't care about conference, or I do care about conference. And what do I need to do for that? And what do I update in the DOM? And it was really crazy. And what ended up happening is you had more data in your application, and you had more data bindings and more elements on your page. Basically, your app just got in this constant cycle of dirty checking, listening to events, updating DOM, and the entire browser broke. It wasn't crazy to hear horror stories in like 2012 of people's, or not 2012, probably 2014, 15, of people's Angular 1 apps running at 1 frame a second and completely locking scroll. That was like pretty standard. More standard than it should have been, and the apps were just slow, honestly. 1 frame a second is terrible. And as we all know, if we've watched Ricky Bobby, it's the fastest who gets paid, and it's the fastest who gets stars on GitHub. So what about React's method? What did it do that was so groundbreaking and crazy? Like dirty checking, that sounds like what we need to do, right? We need to look at what the values are right now, constantly update them to the user as fast as possible. Well, what React did was it made it explicit. You had to call what something's called set state to actually change what values are backing your components. And since we have to call setState anytime something changes that we want to update to the user, this makes it really easy to know when we should re-render. But that's not it, because a lot of times the data doesn't change. So what React did was it took a representation of everything the user's supposed to see, or what we think it is, keeps it in memory, keeps the last thing that they saw in memory, and then when a change happens, it prints out all the HTML as a string or a set of objects, and then runs a diff on all of those. This means you never touch the DOM, you're never blocking the rendering thread until you actually know what updates need to get pushed. What this looks like is you have a bunch of components in your application. So let's say the top is your application, the left-hand side is like maybe your nav bar, and the right-hand side is the main part of your application. And setState gets called, and maybe let's say that that user value changes, and the components say, oh, here are all the components that use that user value that's now changed, and it reruns those render functions. And then it takes the result of those render functions and diffs it against what it thought render was before, and then turns that into like inner text and different update functions. But we're all in 2017, and a wild Redux or Flux architecture has appeared. So what happens is we're setting state at the top of our application constantly. Let's think of a user logging in. You've probably set an event or sent an action that says network request has started, user has tried logging in, user is not authenticated, user has started a network, or the network request is finished, the user is logged in, and who is the user. You've got like 7 events that potentially in our network conditions could happen within like less than a second. And that means that you're hitting set state tons of times at the top of your application. And what that means is that all your components run their render function again and again. But there is a way to stop this. You run into performance bottlenecks because you're running render on all these components constantly. And virtual DOM is faster, but at the end of the day, you're running a lot of code, and you're running it constantly and updating it a lot. So what you end up having to do is this performance optimization called component should update. And you say, oh, the only thing that's changed is loading or user. I don't care about that, and none of my child components care about that, so I can stop rendering and just say, everything from here on is the same as before. The problem is, now you're coupling every component to everything that might be inside of it. So if a top nav, you originally say component should update should only change based on like open on mobile, not open on mobile, and you say, all right, that's the only thing I base component should update on, but one of your child components needs to know about, is the user logged in so I can show them their account page. Well, you've stopped rendering way above. Meaning you have to keep things up to date, and you have to know everything that goes inside of your components to eke out the performance the component should update does. And you're probably thinking, isn't this how Glimmer and Ember work? But once again, it's not. So looking at JSX, here's our create element, and conference can be updated. And what happens is, even if we know that conference has changed, even if we've optimized it using component should update, we have to run React create element for that h1, get the hello string, find the value for conference, update this entire DOM, diff that against the old version of the h1, and then do a bunch of work. Handlebars, the instruction set, looks a little bit different. Notice start h1 element, end element, and then there's this raw static text node. So I've added these comments. They're not shipped to the browser in any way. But what's cool is where under hello, there's that 1. And these numbers are actually instructions to Glimmer and Ember saying what kind of mutations or what kind of information do we send to the browser and what instructions do we do. You can kind of map these one-to-one to like inner text or create element or end element or set attributes. And that number 1 means this is dynamic data. And what's cool about this is inside of this component representation, we actually know everything that can change and everything that can't. So when we insert an element, and that's why I've got the insert at the top, we have to say create a new h1, end the old end the opening tag, create a new text node, and we're going to create a separate text node actually for hello and the conference variable, and then we're going to close everything up. But what's cool is we know the only thing that can change is conference. So when we go to update, we've actually thrown away everything except for conference. We've left alone all the references to the non-dynamic parts of our HTML and the non-dynamic parts of our UI, meaning we don't need to do any more work except for when we just delete those off the page. There's even optimizations that you could do to clone nodes since they're already known and existing to reuse this component elsewhere too. So this is how Ember 2 and the Glimmer virtual machine, or what's under the hood, what's actually running those instructions and sending them to the browser, this is how it actually works. So that means that hello just gets left as a text node and then gets completely deleted from memory. It's just left there. When the h1 gets removed, we know hello will get removed, so we don't need to touch it anymore. It means that we've got really performant updates because the only thing that we're listening for is when conference changes. And what's also cool about this is, remember component should update and how I said it can get out of sync with other child components and other things inside of your DOM? Well, what's cool about handlebars is what actually happens is that conference, that line, that text node that represents the conference variable, always is attached to conference. And it is only updated when conference changes. So it gets kind of, if you're really wanting to look for like a React one-to-one mapping for how this works, it's almost like you created a component just for that one text node and created a component should update for that conference value in that context for that exact component where it's lying, which is really cool. It means you get performant updates without having to do extra work. Nothing can get out of date or out of sync. It's just the way you describe your HTML and describe your variables. So what about some more dynamic data? Here is kind of the top navigation example again with an if statement saying if the user's logged in, show them the account page and a logout page, else show them login and sign up. The output, unfortunately to human eyes, is not as fun, but once again, machines just love this and just can like just go through all this instructions super fast. But what's also cool is since we've described everything and we've got these instructions, this also opens things up. Lori talked about static analysis, and I think Brian talked about some static analysis before today. So what static analysis is being able to look at your code and not actually having to run it or run it with any fake data or anything and know what your application could look like and what it could do. So with handlebars, you know the UI that you could run. Looking at things in the React world, this actually is possible, but you have to start constraining the ways that you use JSX, the way that you use some of your components. And often you end up having to use something like prepack, which is incredibly cool. Prepack allows you to do some of these optimizations like before it ever gets to the browser and do comparisons. But what it's doing is running your React components or running your JavaScript code in Node and then trying to figure that out of what's the best way to bundle things. We can actually do better without ever having to run any JavaScript. It also means that we have the rise of what I like to call static components, meaning, oh, that's not what I wanted. Something like a font awesome icon, right? Components are awesome because we can do things like accessibility and class names and sizes, and we can have this really descriptive and nice way of declaring components. And I can just say, give me a font awesome icon for Pied Piper, and that component needs to do the rest. It needs to build the HTML that represents this. But that HTML is really simple and isn't dynamic. It's not going to change. It's just going to always be like a span tag with a few font awesome classes on it. Well, what ends up happening if you use the Ember Font Awesome add-on is we can actually do this at compile time. So before it ever gets to the browser, there is no actual font-awesome component in your browser. It's just injected HTML everywhere you try to use that component. And it's static, meaning it's not going to change. It doesn't have to be updated. It doesn't have to be tracked. Even cooler with FontAwesome 5, you're allowed to create custom versions of FontAwesome. So we can take and know every different FontAwesome icon that you could use in your application and bundle you a custom version of FontAwesome for just the icons that you use, which is, I think, pretty cool. But I gave this talk at Nash React a few months back. And of course, as the Ember team is wont to do, they made a pull request like 2 minutes before my talk that just blew my mind of how cool it was and changing a lot of things that happened. The JSON that I showed you isn't the final form of what's happening. So everything I've showed you up to this point is what you get in Ember today. If you just ran Ember new project and created a new Ember app, you get all of the optimizations I've talked to up to this point. But Ember has this kind of component-only library version called Glimmer.js, which is like a lower-level version, kind of a slimmed-down version. And it's kind of on the bleeding edge of things. So those instructions that I showed you that were JSON actually can be represented a different way. Tom Dale, in a blog post on the Ember website, said, "We knew that JSON was not the final word in compactly and efficiently representing compiled templates," meaning even though that was really fast, it was really efficient to read, there's still a better way to represent data that you know is going to be static. And that way is to do bytecodes. And this is something that's been enabled in browsers and in Node recently. You're actually able to take a bytecode array, which is basically a representation one level above binary, that you're able to stream data directly to the browser and read it incredibly fast, even faster than parsing. And the other thing is, since it comes in as a stream, you can like stop the instructions at any time. So obvious matrix reference here. So I want to show you what this looks like. So what it looks like in Glimmer.js today, and what eventually is going to happen to templates in Ember without any change, by the way. So this is what's cool about this is there's no breaking change needed to support this in Ember from the client side. So if you write Ember today and you don't do things that are already deprecated, in a few months, hopefully, these optimizations are going to be in your Ember app if you upgrade. Yes, it did side by side instead of up and down. So here's kind of a small Glimmer application. Oh, now it's doing up and down. I've got a top nav, hello, meetup. Glimmer.js by default uses TypeScript. You can use it with JavaScript, but then you have to run and write your own Webpack, and who wants to do that? So I've got link to components inside of all of my list items. And the link to takes in a dynamic value for the route name. And it just yields out, which is kind of like this.props.children. It yields out the inner text of the anchor tag. So it's a fairly straightforward component. And it puts out a not exactly exciting result. But what's cool, this is a website called try.glimmerjs.com. On my slides, you can click on Keanu Reeves as well and get here. And in the bottom, there's this pi symbol, right? Yes, pi. And what happens is as you're writing in this playground, you can click on pi and actually see the binary representation with comments so you actually know what it is because not binary, this is bytecode. The bytecode representation with addresses of what's going on. Personally, I don't feel like reading bytecode and then finding the dictionary to look things up, so the comments are really nice. So these text, tag, primitive symbols, those are the numbers that we saw before in the JSON representation. But what they actually get sent to the browser as now, or in Glimmer.js, is these bytecode representations, which are smaller to store. It means your templates are even smaller before using gzip or any compression algorithm. Your templates are already smaller. They're faster to read. And then these instructions are basically a one-to-one mapping to DOM manipulation or UI manipulation. So what's cool about this is all of this bytecode gets sent to the browser. And yeah, it's a lot bigger because it's a lot bigger app. All this bytecode gets run and sent to the browser. And the cool thing, and this is something that Tom and Yehuda and the Ember team, of course, didn't want to make my life easy. So last Tuesday, they tweeted something out that kind of was shocking to me. Well, it's not that shocking. It's just that it's really cool, and it completely messes up my thought process. Bytecode can be read by anything. And then, has anyone heard of this cool new thing called WebAssembly? Yeah. So there's currently an experimental branch. So if you want to go on Glimmer.js/Glimmer.js, there's an experimental branch on GitHub where they're actually running all of these mutations and all of this bytecode, reading it in directly. They're not having to do JSON parse. They're not having to run any JavaScript to do these mutations and figure out this instruction set in another thread in WebAssembly using Rust, which kind of just blows my mind. And I'm like, now I finally have a reason that I actually need to learn Rust. But what's cool is this optimization is there. And it's set up for that. All right, so some takeaways, because I said I'm going to give us all some takeaways even if we're not writing Ember. You should give it a try if it's been a while or if you've never tried it. I think it's really cool and really nice, and you get these performance upgrades. So the first thing is do less work for static UI. As much as it pains me, component should update is a great way to eke out some performance in React apps. Just be warned that it can get out of date with your state really quickly. Things like, I think it's like Redux Select or something, can help you. Basically, it creates a higher order component that has its own component should update based on what properties you need from Redux. And it's, yeah. The other thing is being able to do more static analysis of your applications, templates, and JSX. So being able to figure out what your app could do and optimize for that without having to run JavaScript, without having to run prepack or figuring out things or rebundling. I think, and this is something that like maybe you can do in your app by yourself, but it's probably going to need to be a community effort in each community to figure out what's the best way that we can do this and make this a default. Like you can do a lot of this stuff in React, not the binary templates and stuff, at least not that I know. You can do a lot of the stuff of like static analysis and like bundling your components into the right sizes and creating component should update based on the render function and things like that, but it's really hard. I think it should be the default. I think that like performance should be built in. Like you shouldn't have to be able to be like, is it out of date? Is it weird? If you do want to know more about Glimmer and the VM and these optimizations, Tom Dale gave a great talk at REACTIVE Conf, and they finally pulled it out of the live stream and like made a nicer video out of it. So I say go ahead and take a look at that. And wow, I actually didn't go too far over time. So if you've got any questions, I can answer some questions as well. Yeah?
So you mentioned that static components are inlined into your bytecode.
Yes.
Does that lead to a lot of duplication? Like if you use a lot of icons, is there like heuristics on what should be inlined and what shouldn't be inlined?
Yeah. So the question was, sometimes if you're using a lot of static components like the font awesome component, you end up having a lot of duplication. So one of the things is that bytecode still can be compressed, so that duplication can be undone. And it kind of, it's a give or take sometimes on components. I think they're working on Glimmer.js it's currently not merged into master, I don't think, static components. So right now for Ember add-ons have to provide that kind of as a build step. That's pretty easy to configure, but each add-on author has to support that individually. But for Glimmer components, like we're looking to make that the default in the build step, and then you can opt out of it. Like if you see, hey, we've got a lot of duplication because I used this really weighty HTML heavy component, maybe at that point it is worth the overhead of building up JavaScript just so that you don't have a more HTML sent. But if you bundle and maybe that duplication is spread across bundles, it may weigh itself out. So it may be on an app-to-app basis that you want to try things out. But there is customization of opting in versus opting out. Really easy. Any other questions? I'll be hanging around. I think I'm going to go to the after party. If you're from Nashville, Cool. Thank you for coming out. Love to see you. I'm one of the co-organizers for Nash.js. So support your local meetups. Come hang out. We've got some cool talks set up for the new year, and would love to see you there. If you're from out of town, we love Nashville. Thanks for coming and making Nodevember awesome. It's one of my favorite conferences to go to, speak at, hang around, whatever. So thank you, and let's keep it up. So.